Hello everyone. So in this video, let's talk about 819 problem name most common word. So as you can see, you're given a string paragraph. This is the complete string and the string array of banned words. You're also given a string array, as you can see, an array of strings that consists of banned words. You have to return the most frequent word that is not banned in this complete paragraph. So the complete paragraph has, as you can see, different type of letters, small letters, punctuation. So I think so it will be given in the complete input, like what will be the complete scope of inputs. It will consist of space, English letters, not numbers but these symbols, and you have to find out the most occurring word that is not banned. And yeah, that is the complete thing. It has to be unique, I think so it is mentioned here. And yeah, it is case sensitive, so the output should be case sensitive that you have to return. Cool. So the complete, as you can see, problem has small constraints. So you can do it in a very brute force way. And whenever you are given a complete bigger string and you have to extract out words from it, the very simple way is that you have to iterate over from left to right. Check that the current character is not a space or the special character. If it is not, you can, let's assume, make a temporary string variable called current. Let's assume make it as an empty string. Okay, let's assume it's an empty string like this. Now take the character. Okay, I've seen B. Okay, take B. I've seen O. Take O. I have seen B. B. I've seen a space. Whenever you see a space, break this and take this as a current word that you have seen. And you will keep on doing this until from left to right. In this problem, you'll not only break at space, but you can break it at any special characters, like let's assume any comma, spaces, punctuations given in the input. The only problem in this method is that how will you handle the last word? Because the last word, because you only break at punctuations or full stops or any other thing. In this, let's assume the string can be like this also. It doesn't end at a full stop or punctuation. It can be only AA. So in that space, in that particular thing, you in such type of problem in which you are just extracting out words, it's better to always add a space at the very end intentionally, so that for the last word also you don't have to do any or handle any special case to extract out the last word. It will be handled in the complete logic itself. So intentionally add a special space at the very end of this particular string, so that when you go from left to right, you will hit every particular character. If it is not a punctuation or a space, keep on incrementing that particular character in the current, and whenever you hit a space or a punctuation, you will break and take the current, you can say, string. Now you just have to keep on you have to keep on accumulating what string you have seen how many times. You can store it in some map, and in the end, from that map, you just have to iterate over the complete strings or the dictionary or the map that you have created, that whether this character is not in the banned list. If this particular word is not in the banned list and this word is the maximum occurring, you will keep on updating the maximum occurring and print out the maximum occurring word. Okay, so that is the complete logic. Nothing much complicated here itself. It's just uh, you can say simple problem, but like you can say implementation. You have to understand that. Okay, so what we have done is that we have taken this map, this paragraph. As you can see, in the end of the paragraph, I've intentionally added a space. Okay, this is the current word that I'm building when iterating over this complete string. Okay, so this is one more thing that I've done. Let's leave it. I'll tell you the later part. So what we have done is that we iterated over all the words of this paragraph one by one. If it is a small character, added in current. Okay, I've seen a character in the string, in this paragraph string. If it is a small word, a small character alphabet, append it in the current. If it is a large character, append it but make it smaller only, so that because we only have to tag it about smaller. If it is not a capital alphabet or small alphabet, it will be space or punctuation. In all that scenarios, what we'll do is we'll take whatever I have seen till now, whatever word, because if it is not a space, if it is not a, you can say if it is a, you can say character of large alphabet and small alphabet, I will keep on appending that particular character to make the current word. Okay, I will keep on appending to make it a current word. When I have got the current word, what I'll do is I will take that current word, because the current word is in current. I will take that current word and increment the particular value of that current word in the map, so that now the word is in current. So I will increment that particular occurrence. So I know that, okay, this has occurred one time or more times. I will just update that particular occurrence in the map so that I know that, okay, it has occurred more. Okay. And in the end, when I have to now start a fresh word, I will just make my current equal to empty so that, okay, now I have a new, you can say, word to be built. I will like store it and I will keep on incrementing. After whole this, I will get the occurrences of all the words in this map MP. Now I have to iterate over all the, you can say, words in this MP map. Check that it is not banned. Now the banned is like you can say an array of strings. So either you have to check that whether this word is in the array of strings or not or not. I will have, like, it's better to just make that particular query faster. What I've done is that I know that these strings will be unique. So I have made a string of set. I've make a set of strings that is band set. Like this band is the band words are there in this array or vector. So what I've done is that I have inserted all of them in the set so that I can query that whether the current you can say word that I have to check that whether it is the maximum occurring, it should not be banned. So it should not be banned, which means that in the banned set it should not present. So I'm iterating over all the words in the map that I have accumulated over finding over when I have iterated over the whole paragraph, and I have taken all the words one by one, and for every word that I've extracted out from this paragraph, I will check that it should not be banned. If it is not banned, I will check that whether whatever is the maximum occurrence word I have seen till now, if this current word that I'm on, is it more than the maximum occurrence I've seen till now? If it is yes, if it is like I am on the ith, that is the current word I am on. Okay, iterating over the map. Now, if the current word I am on the map, if it is greater than the maximum I have seen till now, I will update the maximum and the current maximum word. In the end, I have the current maximum word in answer. I will just print out the answer. Okay, that's a complete, you can say, implementation of this particular problem. So this is a for loop. Okay, and then this is just a for loop, nothing much. I have inserted in the set here as well, and then checking in the set will take for every word, which is like n log n. So like high level wise, it is n log n, but like you can say, but this actually comes down shorter only. So m log n, something like that it becomes, but overall it is a very small complexity problem because the constraints are pretty much small. Okay, so that's the complete logic and the good part for this particular problem. I hope you understand the logic of it. If you still have it out, you can mention in the comment box for this particular video. I will see you in the next one. Thanks for watching and bye.